C and D are on the line, right? This line here, this is this line equation. You want to find out. Here, let me explain first. 732 is this point here. So for this point, the housing address confirm is t equals to 0. No question. Okay. Now the question is, if you want to find A and B, you just need to find the housing address of this guy here. What is the housing address? Okay. So you just so you just take 10 AB equals to 732 plus T130. Okay, then you solve for the T. Then once you get a housing address, your life is good. So this case is 10 equals to 7 plus T. Then the X component, Y component, just add them up. So it's 3 plus 3T. B equals to, oh, nice. Good. So B is 2. Then T is how much? T is 3. So A is 3 plus 3 times 3. 9 plus 3 is 12. So hence A is 12. B is 2. Part 2. You want to find the angle between the y-axis and the line. So this is the y-axis. The line. Y-axis is here. Okay. Y-axis will mean that the direction says 0. This will be like 0, 1, 0 direction here, the unit vector. Okay. So then this is the line. The direction of the line is 130, 130. Okay. Okay, so I can put this as D. Then this maybe this direction of Y, I just put dy lah, subscript Y. Okay. So the thing is, I want the acute angle here. So part 2, the dot product dy sine theta. Okay, that's it. So you just dot it. 130, 0, 1, 0. D is 1 square plus 3 square plus 0 square. 0 square plus 1 square plus 0 square cosine theta. 3 1 plus 9 1. 3 over root 10. In calculator. Theta is cosine inverse 3 over root 10. So dot product, that will be 18.43 to 1 nearest 0.1 degree. Nearest So you try to understand the question. I think this is what they're trying to call angle bisector. Okay? I think the common mistake is if you draw it too symmetrical, you may assume some stuff which is not right. So let me explain. So this is what's going on. You are told that this is equal to this guy here, right? When you draw this diagram, you draw it symmetrical, right? You will have a problem. The problem is you assume that this is equals to this one, and then this is like this one, like that. Wow, then you say, oh, correct. Then it's a bit fact no lah. It's not correct. Okay? So it's not correct, bisector. Because you drew it very, very, very symmetrically, so that's why you may assume it's like that. Always challenge your assumption. So you draw it slant. So let me just give you an example. You just because angle bisector doesn't always have to be like so let's say you draw this angle here. So let's say I have this over here. So this is one angle, this is like another angle. The angle have to be the same. So I'm drawing, let's say this is slightly equal to this one. Now it's in this way. It's like drawing like that, right? You realize now you won't get this equals to this one anymore. You won't think that it's symmetrical. So angle bisector, please don't assume. You just stretch, okay? Slant it. I always say you only need dot product, cross product, and magic triangle, okay? I swear by these three things. That's all, okay? So then you realize that I always use the same concept. from no matter how we solve the question, the 100 questions in the question bank are all the vectors, because is your senior or us. You check. I think the last I checked, there are 200 questions on vectors. Any question, any obscure question you want to ask, right? Is your senior already asked already? Your tutorial, go and check. I only use these three concepts. So what you need to understand is, first thing, I'm gonna label my C and my D lah. I think that one is quite okay. So my C is okay. So this one here, if this angle is equal to this angle, so what I can say is essentially the can I label this as a C dot Q is equals to mod C mod Q cosine theta. Okay, let's say alpha lah. So okay, so this case here, if I use the dot product of this line here, C and Q, I'll get this dot product. Okay. Then I use the dot product of C dot Q dot D. I get this dot product. Maybe I'll just pause a bit. The next part, what you do is, you know that because the angle is the same, so it makes sense for us to manipulate this one. So from here, cosine alpha is equals to C dot Q over mod C mod Q. Cosine alpha equals to Q dot D over mod Q mod D. Okay. Then you just equate them. Equating 1 and 2, I will get C dot Q over mod C mod Q equals to Q dot D equals to Q. There you go. It's all the same concept, okay? Because we already have got, okay, this one can cancel away. So I'm gonna just label this down nicely. Oh, sorry, I canceled the wrong thing. So these two will cancel away. Then this guy will be C dot Q mod C Q dot D over mod D, right? We already have D and C, not an issue. D and C is easy game for us because we got C and D here. But what the problem now is, what is Q, right? It's the same concept. If Q is on the line CD, you just, for some T real value, you just let, so for some lambda T real value, you know that OQ will take the line equation. Then you use that to try, okay? So now I'm just gonna put everything inside my Q, which is this one, my C, which is this one, my D, which is this one. Sub everything inside. Happy. Anyone want to ask any question? Do you see that I don't mod it, guys? I don't mod this thing because now whether it's acute or obtuse, it makes sense. It may be acute or obtuse. This case here, you don't mod it because it may be of different. You see, you don't modulus it. If you modulus it, you have two solutions. But in this case, you don't do that. Don't do that because whether it's obtuse, you can, this alpha can be obtuse or acute, depending on this. Okay, so just normal manipulation. This 248 I'll multiply above. Then I can simplify this. Then solve for the t. Okay, so this is it. I solve t equals to 1. Then I get my q. OQ is OQ is it'll be 8, 6, 2. They want the coordinates or position vector. So like nice. So that is the position vector of Q. Got it.